In this video, we are continuing to learn about vertex form. Remember, this is vertex form and this is my vertex. But before we begin this lesson, let's review the transformations of function graphs. And I did upload this handout for you, so please pause the video, print this out, and have it with you while you're watching this video and while you're doing your homework. So remember, if we multiply the function by -1, we have a reflection over the x-axis. If we add k to the function, we are shifting the function up k units. And if we subtract k from the function, we are shifting the function down k units. If we add h to x, we are shifting the function to the left h units. And if we subtract h from x, we are shifting the function to the right h units. If we multiply the function by a, we are giving the function a vertical stretch or compression. And remember, vertical compression and vertical shrink mean the same thing. If a is greater than 1, remember we have a vertical stretch. And if a is less than 1 but greater than 0, we have a vertical shrink or compression. Example number 1. Now that we have reviewed all of that, have that handout with you so you can refer back to it while you're watching this video and while you're doing your homework. So example number 1 says graph each function and then compare the graph to the parent function. And remember, the parent function is y equals x squared. So the first thing I'm going to do is I'm going to graph this. My vertex is at 1, -7, and we talked about how to identify the vertex from vertex form in the last video. So my vertex is at 1, -7, so that means my axis of symmetry is at x equals 1. And so then what did I do? I created 2 points and I reflected them over the axis of symmetry, and I created my graph. And you have done that before, so this should be review. But now, how is this graph related to the parent function? What did we do here? In relation to the parent function, this graph has a vertical stretch by a factor of 3. A is 3. And we shifted the graph right 1 and down 7. So pause the video and make sure that you understand how and why there's a vertical stretch by a factor of 3 and a shift of the graph right 1 and down 7. And then when you're ready, go ahead and hit pause, graph this function, and compare the graph to the parent function. So here's the graph of the function, and how is this function related to the parent function? There's a vertical compression by a factor of 1/3, and the graph is shifted to the left 6 and up 2. Example number 2. Describe how g of x is related to f of x. And then, what is g of x? Okay, so I have function f here. Then I created function g. How did I create function g? What did I do? I shifted function f to the right 4. And how did I do that? What did I do? I subtracted 4 from x. And when I did so, I created function g. Pause the video and make sure that you understand what's happening here. I had my original function f, and I created function g. How did I create function g? What did I do? I shifted function f to the right 4. How did I do that? I subtracted 4 from x. I subtracted 4 from x right here, and this gave me the new function g. And what I want you to do is go to Desmos.com. Go right now to Desmos.com and type in this function right here and hit enter. And then type in this function and compare the two and see how function g is related to function f. Now let's look at this example. Again, I have my original function f here, and then I'm going to create function g. How am I going to create function g? What am I going to do? Well, I'm going to take function f and I'm going to multiply it by 1/2. Or you can say I'm going to divide it by 2. Same thing. I'm going to take function f and I'm going to divide the entire function by 2. And that's what I did here. And that's how I got my function g. In doing so, what did I do? I gave it a vertical compression by a factor of 1/2. And when you get to Algebra 2, you will learn more about this and what exactly this means on the graph. But right now, you just need to be able to identify vertical compressions and shifting, and you need to be able to create the new function. Okay, so now go ahead and hit pause and work out these two on your own problem. Describe how function g is related to the original function f, and then write what is function g. Okay, let's look at this example here. What am I doing here to create function g? I'm taking function f and I'm multiplying it by 3. I'm taking the entire function f and I'm multiplying it by 3. And in doing so, I'm giving it a vertical stretch by a factor of 3. Now let's look at this one. What am I doing here? I'm shifting the function down 7. In order to create function g, I'm taking the original function f and I'm shifting it down 7 units. And how am I doing that? I'm subtracting 7 from the function. So here are the answers. Pause the video and make sure that you understand what I did, and if you have any questions, please email me. And finally, example number 3. Write a quadratic function in vertex form whose graph has the given vertex and passes through the given point. So we know this is vertex form, and we know we have a graph that has a vertex at 1, 2, and passes through the point 4, 11. So I know my h and my k, and I know my x and y. I have an xy coordinate point. So I know my vertex, which is hk, and I have an xy coordinate point. So all I'm going to do is plug them in and algebraically solve for a. Once I know a, here a is 1, then I can create my quadratic function in vertex form. And remember, this xy here represents any xy coordinate point that's on this graph. There's an infinite number of xy coordinate points that are on this graph. So now go ahead and hit pause and work out this on your own problem. And here's the answer. Again, I know my h, and I know my k, and I also have an xy coordinate point, x, y. Then I just solve for a algebraically, and I can create my function in vertex form.